One of the most common ways to write the equation of a line is slope-intercept form. That probably looks familiar to you. In slope-intercept form, the m, the number that multiplies the x, is the slope of the line, and the b, that's the constant term, is the y-intercept of the line. So if we've got an equation of a line y equals 3x plus 2, we know that the slope of the line is 3, and the y-intercept is 2. Knowing the slope and the y-intercept also allows us to graph a line very easily. The first thing we can do is graph the y-intercept. In this case, we know that the line will cross the y-axis at 2. And since the slope is 3, we can think of 3 as 3 over 1 to see that from that y-intercept, if we go up 3 and to the right 1, we can find another point on the line. And with 2 points, we can always graph our line. But there are other ways to write the equations of lines. We could have a line that looks like this, 2x plus 3y equals 6. Well, what if we wanted to graph that line? We don't know its slope. We don't know its y-intercept. How do we graph it? Well, this equation is in what's called standard form. In standard form, the x and y terms of the equation are on the left side of the equal sign, and the constant term is on the right side. Also in standard form, we won't see any fractions in the equation, and the coefficient of the x term, that's the a, will always be a positive number. Well, one way we could graph this line is to just rewrite it so that it's in slope-intercept form. So we could subtract the 2x from both sides, and then divide both sides of the equation by 3, and there it is. We've got our equation in slope-intercept form. Now that looks familiar. We know that the slope of the line is negative 2/3. The y-intercept is 2, so that gives us all the information we need to graph a point at 2 on the y-axis, and then go down 2 and to the right 3 from that point to get a second point on the line. And there we have it. There's our line. But what if we didn't want to go through all the trouble of rewriting the equation in slope-intercept form? Could we still graph the line? Well, as it turns out, we could. We would just have to look for different information. If we can find the y and x intercepts of the line, we'll still have 2 points on the line, and we can graph the line. To find the y-intercept, we'll let x be 0 in the equation. And when we do that, we can see that y is 2. So our y-intercept is the point 0, 2. To find the x-intercept, we'll let the y be 0 in the equation. And now we can see that x is 3. So the x-intercept is the point 3, 0. If we graph those 2 points, 0, 2 for the y-intercept and 3, 0 for the x-intercept, we've got the 2 points we need to graph our line. One thing that made graphing with intercepts really easy with this line is that both the x and y intercepts are integer values. In other words, they fell along those grid lines on our graph. That's going to happen if the coefficients of the x and y, that's the a and the b, are both factors of the constant term, that's the c. And in this case, that's what happened. 2 is a factor of 6, and 3 is also a factor of 6. If that's not what you see in the equation, then those x and y intercepts will not both be integer values, and that may make graphing by finding intercepts a little bit trickier to do. One other thing that you may be wondering about standard form is, why do we even need it in the first place? Well, sometimes standard form is a little easier to use if we're trying to write the equation of a line from a word problem. Here's an example. Suppose we know that Jaden spent $9 on some candy bars. The Twix bars cost $1.25 each, and the Mars bars cost $1.50 each. Now, how do we write an equation that describes what's going on in this problem? Well, let's see. We don't know how many of each kind of bar he bought, so we could say X is the number of Twix bars and Y is the number of Mars bars. We know that every Twix bar cost $1.25 and there were X of them. So the total cost of the Twix bars is 1.25 times X. And since the Mars bars cost $1.50 each and there were Y of those, then the cost of all the Mars bars is 1.50 times Y. Now, if you put the cost of the Twix bars and the cost of the Mars bars together, you get the total spent on the candy bars, which is $9. So there you have it. We've got an equation almost written in standard form. Let's multiply everything by 100, and now we've got an equation written in standard form. So can you see that standard form is what makes sense for this particular problem? Yes, so you just have to think about what's the information you're given and what form of the equation makes sense for that particular set of information.